We are getting started with a brand new unit on probability distributions. And the first type of probability distribution that we're looking at is something called binomial probability. And before we get into binomial probability, I have to teach you how to do one type of calculation, and that's called calculating combinations of things. So just a fair warning, today might seem like I'm going all over the place, but eventually it will all come full circle and you'll realize how they all tie together. So let's get started on calculating combinations. And we're going to start by looking at when you order takeout food. Sometimes it's a little awkward when you decide, should you leave a tip or should you not leave a tip? You know, when you go to a restaurant, the waiter or waitress is going to be waiting on you. They're going to be taking your order. They're going to fill up your water. They're going to be checking on everything, making sure it's okay. It's a rough job, sometimes dealing with these crabby customers, and you generally leave them 20, 25% or so as a tip. But when you order takeout food, do they really justify earning a tip when they've just handed you a bag of food? Some people say yes. Some people say no. I would generally say yes. Just be polite. But long story short, let's just say that on average, 35% of people that order takeout food end up leaving a tip at a certain restaurant. And we have 5 separate customers that end up picking up their takeout orders. I want to determine the probability that the first 2 leave a tip and then the last 3 do not leave a tip. So I'm going to draw 5 slots representing the 5 customers. And now I'm saying that the first 2 have to leave a tip. So they're going to be good customers. They're going to be generous and they're going to leave a tip. And then the last 3, they're mean. They don't leave a tip. They're kind of selfish. So let's calculate this probability. We do know from the information in the problem that 35% of the people leave a tip. So the chance that this first person leaves this tip is 35%, 0.35. Now they're going to eat their food, and a new customer is going to come in, completely independent of the other one. So the chance that they leave a tip is also going to be 35%. And then the next person is going to come in, and the chance that they do not leave a tip is 65%. And you can reason that because if 35% do leave a tip, the other 65% do not. They add up to 100%. And the chance that this person doesn't leave a tip is 65%, and this one also 65%. So to find the probability of this sequence of events happening, for this to happen, then this, then this, then this, then this, you just have to multiply them. So we're going to multiply these all together. And if you multiply them, we get a probability of 0.0336, which is about a 3.36% chance that the first 2 leave a tip, and then the last 3 do not leave a tip. 3.36%. So hopefully that one wasn't too bad to calculate. Now I've got a different type of question for you. And in this question, it's saying, what's the probability that 2 of them leave a tip and 3 of them don't? Now I'm not specifying the order that they have to be in. I'm just saying any 2 of the 5 could leave a tip. So bear with me as I draw out a bunch of slots here. I'm going to be drawing 10 rows of 5. One, 2, 3, 4, 5, 6, 7, 8, and one more. 1, 2, 3, 4, 5. Okay, sorry about that. So what we're going to do is we're going to find all the different ways that 2 of them could leave a tip. We could have exactly what we saw in the first situation, where it was the first 2 could leave a tip, and then the last 3, nope, they're mean. We could also have the first and the third could leave a tip, or the first and the fourth could leave a tip, or the first and the fifth person could leave a tip. Or the first person might not leave a tip at all, and you could have the second and third person leaving a tip, or the second and fourth person leaving a tip, or the second and fifth person leaving a tip, or we could have the third and the fourth, or the third and the fifth, or it could be the fourth and the fifth. So you'll notice that there are how many different ways that two people could leave a tip? Well, you watched me draw out all those slots. There are 10 different ways that we could have two of them leave a tip and three of them not leave a tip. Now, what we see is, if I want to calculate the probability of this row, we can just multiply them. This is 0.35 times 0.35 times 0.65 times 0.65 times 0.65, and we've already done that calculation. It's 0.0336. And if I want the probability of this row happening, well, this is going to be a 35, this is a 35%, and all of these other ones are 65, which, if I multiply them, will be the exact same as that top row. It's going to be 0.0336. And similarly, this is 35, this is 35, all the other ones are 65s, and if I multiply them together, it's 0.0336. And every single one of these will have a 3.36% chance of happening. So to find the probability of two of them leaving a tip, I could just add all of these up, or to make it quicker, you could just multiply by 10, because there's 10 of them, and you end up with a 33.6% chance of that happening. So there were 10 different ways that two people could leave a tip and three of them not leave a tip. And later on today, I'm going to show you how to calculate this number 10 over here. Before you move on, I want you to look at this thing called Pascal's triangle, and I want you to just figure out the next row in Pascal's triangle. So go ahead and pause the video, and when you're done, come on back and we'll look at a couple unique properties in Pascal's triangle. All right, were you able to find out all the cool properties of Pascal's triangle? I bet you didn't come close to finding all of the cool properties. I'm going to show you a couple of them. Let's just show you how to get the next row. It starts with a 1. If you add, let's just say, any two of these hexagons, 5 plus 10 makes 15. 15 plus 6 makes 21. 4 plus 1 makes 5. So that's kind of how you fill the next row, is you just take the two above it. So 1 plus 7 makes an 8. And 7 plus 21 makes 28. 21 and 35 is a 56. We get 70, 56, 28, 8, and 1. You'll notice it's symmetrical. A couple other cool things. Let's say you do 11 to the 0 power. It equals 1. 11 to the first power is 11. 11 squared is 121. 11 cubed is 1,331. I bet you know what 11 to the fourth power is now. 14,641. So once you get to this next row with the tens in there, it still works. You just have to carry some digits over. Let's look at something else kind of cool about this. I'm going to break it off into rows and add up all the numbers in each row. This is 1. 1 plus 1 is 2. 1 plus 2 plus 1 is 4. 1 plus 3 plus 3 plus 1 is 8. 1 plus 4 plus 6 plus 4 plus 1 is 16. 1 plus 5 plus 10 plus 10 plus 5 plus 1 is 32. Are you noticing a pattern here? The next one would be 64. All right, so You get powers of 2 when you add those together. One other kind of cool one. Let's take a look at this. 1 plus 3 is 4, right? Well, that's 2 squared. 6 plus 3 is 9, and that's just 3 squared. 10 plus 6 is 16, and that's just 4 squared. 10 plus 15 is 25, which is 5 squared. And this one gives you 6 squared, and so on and so on. So tons of hidden, wonderful, beautiful things in mathematics that are all derived from this Pascal's triangle. I want you to make sure you know how to generate a row in Pascal's triangle. So there's that. Now let's go on to a formula for determining the number of combinations. This formula is going to be, sometimes you see it written like this, n with an r. It's like a big parentheses with 2 numbers stacked on each other. Or you might see it as NCR. C stands for combinations. So you'll see them both ways. Typically, I like writing it this way with the parentheses way. But your calculators are programmed to write it like that. Anyways, the formula for that is n factorial over r factorial times n minus r factorial. Don't be super freaked out by the factorials. They're not so bad. So we're going to use the formula to calculate the following. We have 14 choose 2. So that's kind of how you say it. You have 14 things and you're going to choose 2 of them. Pretend McDonald's has 14 different toppings they can offer on their sandwiches. You're going to choose 2 of them. So how many ways could you choose those 2? So it's going to be 14 factorial over 2 factorial times 14 minus 2 factorial. I'm going to simplify this a little bit. So we end up with 14 factorial over 2 factorial times 12 factorial. And what a factorial means is just multiply it all the way down to 1. So 14 factorial is 14 times 13 times 12 times 11 times 10, yada, 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 all the way down to 1. And on the denominator, we're going to have 2 times 1, that's this 2 factorial, times 12 times 11 times 10 times all the way down to 1. That's this 12 factorial. You'll notice something really, really, really nice happens. Cancel, cancel, cancel. Everything going down to 1 would cancel, and you're left with this calculation here. So 14 times 13 divided by 2 times 1. I would cancel the 14 and the 2 to be 7 and 1. 7 times 13 is 91. And there's your calculation. So a lot of things just end up canceling out, and you get 91. Let's go ahead and do one more together. This one would be 10 factorial over 7 factorial times 10 minus 7 factorial. I'm going to simplify it a little bit. So we get 10 factorial over 7 factorial times 3 factorial, which gives us 10 times 9 times 8 times 7 times 6 times yada, 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 all the way down to 1. Over 7 times 6 times all the way down to 1. That's the 7 factorial. Times 3 times 2 times 1. That's this 3 factorial. This 7 times 6 times 5, 4, 3, 2, 1 will cancel with 7, 6, 5, 4, 3, 2, 1. All of that goes away. So we are left with 10 times 9 times 8 divided by 3 times 2 times 1. So we end up with 720 on top divided by 6 on the bottom, which gives us 120. So go ahead and try the next 2 on your own, and then see if by looking at this one right here, see if you can see how it relates to this goofy thing, Pascal's triangle. And then come back next video and then I'll tell you what's going on with it.